side lengths, and you can identify its angles. Board to paper, make sure you have that. The first 5 minutes is going to be a lot of writing. If I have to count you one time, you'll be in here at recess if you don't have it on.
Yeah. Why did you pick the biggest word? Isosceles or whatever. It's a confusing word.
Oh, I didn't think it. The math was
That's just confusing.
The map. It sounds like a woman.
Check your name. Check on. Raise your hand. If you have a comment, just to get a feel for if you've ever used these words in 5th or 6th grade, give me a thumb up if you've heard scalene, isosceles, equilateral. A thumb down if you haven't. I'll just take a hand. Aiden, that's your second for talking. Jackson, first for talking. So those 3 words you've likely heard before. We're going to classify them in a little different way, and you're going to have to use the knowledge slightly one level up from 6th grade. When you look at a side length for scalene, a scalene has all sides that are different. This also makes all the angles different. Scalene, when you hear the word, you're going to think of a really scary looking triangle. I like everything to be really neat and similar and common, and a scalene isn't that. A scalene is extremely different. Every side is different from the other. Draw one side length that looks like this. It's okay if yours is slightly different than mine, but it should be kind of similar. Draw the bottom line like this. Draw the top connecting the two. All side lengths are different. Put 1 dash in the side, put 2 in the bottom, put 3 on the diagonal. The dash marks tells you that they are different. Those are tally marks, and that's what tells you the side length is different completely. That's your scary scalene triangle. Let's look at isosceles. Isosceles has 2 sides that are the same. We'll make this one green. 2 sides are the same, which makes 2 angles the same. Go ahead. Draw your triangle so it matches mine, sketch it out. These 2 top sides are the same. Make them look very similar. The bottom one is different. This one's much shorter than the others. Since the 2 are the same, put this 1 tally mark to notify it's the same. When you think of isosceles, you're thinking of John Morant or your favorite basketball player isoing against the other team. If you see an iso triangle, 1 side length is different. This side length is isoing the other ones. This is different. There is 1 iso from the rest. This is different than the rest. That's an isosceles. Say scalene on 2, 1, 2. Say isosceles 1, 2. Those are 2 types of triangles you'll see today. Last one is an equilateral. Say equal on 2, 1, 2. Equal is the key word. All sides are the same, which makes all angles the same. We're going to sketch that out. It might not be exact because you don't have a ruler, but we'll just use our pencil and our brain. If you have an equal triangle, you're going to have 1 side length about that size. The other is going to be very similar, and the other one will be like that. All angles are the same. How many tally marks should the other sides have? Just 1. That's 1, that's 1, that's 1. This is called an equilateral. You think equal. It literally sounds like what it is. It is equal. That's side lengths. You can also classify it with angles. Down here, cross out sides. I didn't fix this in my notes. You're going to write angles. Cross out sides, write angles. Second box, cross out sides, write angles. There are 3 types of angles that you'll see. You might see an acute angle. What does an acute angle mean? You've heard this from 4th and 5th grade likely. It's like a cute little angle. Your teacher probably like drew a little cute tiny angle. And I'll take a silent hand. Evelyn, what is that angle going to be? Yeah, so this acute angle, if it's an acute triangle, all angles have to be less than 90. Every angle is less. So let's draw an equilateral again, because that's the easiest acute. Every angle is less than 90. It is not a right angle. It's not more than a right angle. Everything is less. If you want to draw a right angle, one of the angles has to be a right angle. A right angle is how many degrees? Look up at the complementary sign. How many degrees? I'm going to pause it. How many degrees is a right angle? Baron? 90. Cool. So one right angle has to have one 90-degree angle. That makes it right. If it's obtuse, cross out all. One angle, cross out all, put 1. If it's obtuse, one angle has to be bigger than 90. One angle is more than 90. Acute is 1 less, right is 190, obtuse is 1 more. Make your first angle look like this. It's a giant obtuse angle. There's your one obtuse. The other one connects it. That triangle is obtuse. You can make it right side up, whatever you'd like. Triangles can be flipped all over the place. They won't always be exact. Skip this first section. You're going to see that most problems are going to give you congruent sides with a tally mark like we did. Your tallies here show that every side is the same. Congruent angles are going to have an arc like they do here. Looking at the triangle on the right, what type of triangle is that? All the side lengths are the same. All the angles are the same. Is that scalene, scary, iso, isosceles, or equal, equilateral? What type of angle is that? Evelyn?
Equilateral.
Right, equilateral. What type of angles do they have? If this is 60, and this is 60, and this is 60, what type of angles is this triangle? Acute, obtuse, or right? Are all angles less than 90? Is 190, or is 1 more? John? They're acute. It's a cute little triangle. So you're going to call this guy first name acute, last name equilateral. This is an acute equilateral triangle. Acute equilateral. You're going to do the same thing with these 3 triangles. Start out by looking at the angle measures. Is this acute, right, or obtuse? Acute, right, or obtuse? Turn and talk, 20 seconds, go. If you get the angles your partner agrees, figure out what the lengths are going to be. Scary, iso, or equal. Does it have a 90? Is it right? Is it acute or is it obtuse? Does it have a 90? It'd be right. First, do the angle. Do right, acute, or obtuse. There's one that I see that's more than 90, huh?
Well, doesn't it say? Oh, wait.
No, just 190. Yeah. 3, 2, 1. Right, acute, or obtuse. Tatum. Number 1 would be
Number one.
right, acute, or obtuse.
Right,
It's right because it has a 90. Start that first name. It's a right angle. And it has two sides that are the same. One side that could be John Morant's is different. This is an iso triangle. What do I call that again? Go back in your notes. You're going to be doing a lot of flipping today. Taylor, what's number 1 called? Is it a scary, iso, or equal triangle? It's isosceles triangle, right? Isosceles. This is called right isosceles. Number 2, look at the angles first. First name, is it right, obtuse, or acute? Does one angle measure above 90? Does one angle measure above, John? Yeah, this is obtuse. Check out the type of triangle. Two sides are the same. One side is John Morant. What is this one called? It is trying to iso the rest. The full name of it is what, Lily? Good. And last one, check out all the degrees. Is it acute, obtuse, or right? Jackson, number 3. Are all? Is there one angle above 90?
I mean acute.
This is acute. It's a cute little triangle. And does any side length equal the same?
It's a scout.
It's a scary scalene triangle. We'll call that acute and scalene. Acute and scalene.
Could I just, excuse me, Mr. McAtee, do I write the whole word? I'm not gonna be able to write that. I'm not gonna be able to remember that. Is that whole?